Hello, students. So good afternoon, all of you. Okay, we will start our class within few minutes. I'm waiting for other JNV students to join the class. Fine. So before that, I will just launch the technical check. Okay. So I have launched a technical check. If there are some network issues or any audio video issues, you can let me know. So we will sort it out. Right. Okay. I hope technically everything is fine. Good, good. Okay. So today, we will study about the organic chemistry. We are continuing the organic chemistry series, right? So basic principles and techniques we have almost covered. So we will study some more techniques or we will revise what we have studied in the last class. Okay. Quantitative and qualitative analysis. Then after that, we will start our new organic chemistry chapter, that is hydrocarbons. Hydrocarbons. Okay. So it's all about organic chemistry. If your base is clear in 11, you can easily score any question during your 12th class. Otherwise, it will be vice versa. It will be difficult for you. Okay, that is it. So before wasting any time, so let us start it. So technically everything is fine. So this is based on last class for recall. Okay, so let us read the question. So what is the question here? So Geldas method, okay, Geldas method is not applicable to which of the following? So we have studied this point in the last class. Nitro compounds, SO compounds, pyridine. So which is the correct answer for this question? You two friends, you can give me the correct answer in the chat box. So the correct answer that I can say nitro compounds. Jaldas method is not applicable. Then for pyridine, it is not applicable. For SO compounds, it is not applicable. So what is the correct answer? That is all of this. Okay, so this is our Jaldas method. Jaldas method is not applicable to which of the following compounds. This Jaldas method is used for what? Jaldas method, Dumas method for the estimation of nitrogen, right? So this is what we have studied in the last class. Jaldas method is not applicable to compounds containing nitrogen. So nitro compounds. Then second one, SO compounds. Last one, if nitrogen is present in a ring. Why it is not applicable to these compounds? Because they cannot form ammonium sulfate. So Jaldas method is based on ammonium sulfate. So from the ammonium sulfate, we will discover or we will find the percentage of nitrogen present. If these compounds are not forming ammonium sulfate, then how can we use Jaldas method? So that is it. Okay, that is a recall question for you. Then this estimation of halogen. So that also we have studied already, qualitative analysis. Same thing, sodium fusion extract, let's say test. Okay, so we will similar kind of reactions here also. So have a carriers too. Then organic compound. Okay, organic compound, that is very important. So we want to find the percentage of element present in the organic compound. Then what are the other things added to this carriers too? So there is a 2, then organic compound is added, then silver nitrate is added. AgNO3, silver nitrate, right? Then fumic nitric acid. So nitric acid, what is that? So we have HNO3, fumic nitric acid. Then we have silver nitrate, we have AgNO3. Then, so what is happening here? Organic compound plus HNO3 plus AgNO3. It is heated in a furnace. Then we will get what? So what is formed? So again, qualitative analysis similar to qualitative analysis. If carbon and hydrogen is present, they are oxidized to carbon dioxide in water. So we have used Lebig's method to find the percentage of carbon, to find the percentage of hydrogen. Okay, then halogen is present. That is X. I can write X, right? So X. Then Ag plus AgNO3 we are adding. So X and Ag plus. So what will be formed? AgX. That is silver halide will be formed, right? So silver halide is formed here. If it is chlorine, then AgCl will be called. Then if it is bromine, AgBr will be formed. If it is iodine, AgI is formed. Then you know the color AgCl, it is white. AgBr, pale yellow. AgI, it is yellow in color. So we have studied that already. Okay, so silver halide is formed. So based on the silver halide, we can find the amount or percentage of halogen present in the organic compound. So let us find out for the halogen and a sulfur. So estimation of halogen. Same thing, we are repeating the process. So silver halide is formed. So that is filtered, washed, dried. And after that, we are taking the weight of silver halide. Okay. Then I'm assuming that the mass of organic compound. So we have an organic compound. It has m gram. That is a mass. Then AgX is formed. Mass of AgX, that is weight, right? So I'm taking it as m1 gram. Okay. Then what is happening? 1 mole of AgX. So here we have AgX. In that there is 1 X halogen. So 1 mole of AgX contain 1 mole of halogen. So AgX only 1 halogen, right? So 1 mole, 1 mole. Okay. Then mass of halogen. How to find the percentage? Your marks obtained divided by total marks into 100. So we have to find the mass of halogen divided by the mass of organic compound. We know the mass of organic compound is m gram. So mass of halogen in m1 gram of AgX, what is that? Atomic mass of halogen into m1 gram. Okay, divided by molecular mass of AgX. The last class we have done this. Okay, that is why I'm not repeating it again. So mass of halogen that is found. Then how to find the percentage of halogen? So percentage of halogen that is equal to mass of halogen divided by mass of organic compound into 100. So what is a mass? So that is found. So add that. Then in the denominator, we have to add m. What is m? Mass of organic compound. To find it into percentage, okay, into 100, we have to take it. So that is the equation for this halogen, estimation of halogen. Suppose in this, what is formed? AgCl is formed. Then how to do that? So atomic mass of X, that is our halogen, chlorine, that is 35.5. Okay. Then molecular mass of AgX, how to find that? Ag, what is the mass? So 108. 108 plus 35.5. So I will get 143.5. That is a molecular mass of AgX. Here it is AgCl. So 143.5. Suppose I have AgBr. So in the numerator, atomic mass of Br. What is the atomic mass? Br. Okay, Br, we have 80. Then what about the molecular mass of AgBr? So we have to add that 80 plus 108, right? So I will get 188. That is a molecular mass of AgX. If it is AgI, if AgI is formed, so what is the atomic mass of iodine? That is 127. Then molecular mass of AgI, how to find that? So we have to add 108 plus 127. So I will get 235. Okay, so percentage of chlorine, that is equal to 35.5 into m1 into 100 divided by molecular mass of AgCl 143.5 into m, that is the mass of organic compound. So you can find this, you have to substitute the values and find the answer. Okay, so that's it for the estimation of halogen, right? So for chlorine, for bromine, for iodine, we have studied. Then, so estimation of sulfur, similar method we are using for sulfur also. First, we have a carriers too. So sealed capillaries, then we have to take organic compound, right? So to that organic compound, we are adding sodium peroxide. So we have studied sodium peroxide in the last class, Na2O2, hydrogen peroxide, you know. Or you can also add nitric acid, fumic nitric acid, very dangerous. Then, so what is happening? So we are heating that, right? Then some reaction is taking place. Sulfur, I'm taking HNO3. It reacts to form H2SO4. So H2SO4, that is very important. Then in the next step, okay, actually, we need the equation, the final product. So using that equation, we can find the answer in the entrance examination. So before that, we have to find what is the final product form. So based on the final product only, we can find the percentage. Okay, so first up, H2SO4 is formed. Then after that, we have sulfuric acid, H2SO4, we have sulfuric acid. Then we are adding what? We are adding barium chloride. So we are adding excess amount of barium chloride, that is BaCl2, solution water. Then we are getting barium sulfate. So we have H2SO4. Then to that, we are adding excess amount of barium chloride. So we will get barium sulfate. So barium sulfate, in that sulfur is present. So based on this, we can find the percentage of sulfur in the organic compound, right? So this is a reaction taking place here. So you have to remember the final product and the equation, how to write the equation, how to find the percentage of sulfur. So let us find it out. So we have barium sulfate. So that is our final product. Based on barium sulfate, we have to do the calculation. So we are taking the weight of barium sulfate, right? Initially, we have an organic compound. What is a mass? That is m gram. Okay, in the question, they will give the mass. Then after that, we are finding the mass of barium sulfate that we are taking it as m1 gram. Okay. Then after that, 1 mole barium sulfate. So here, barium sulfate, there is 1 sulfur, right? So 1 mole barium sulfate, what is the molecular mass? That is 233 gram. Okay. Then in that, there is 1 sulfur. That means 32 gram sulfur is present. So in 233 gram of barium sulfate, 32 gram of sulfur is present. Then what about 1 gram? If I'm taking 1 gram barium sulfate, so what is the amount of sulfur present? That is 32 divided by 233 gram of sulfur will be present. So here we are taking m1 gram of barium sulfate. Then what is the next step? M1 gram of barium sulfate contains 32 divided by 233 into m1 gram of sulfur. So we found the mass of sulfur. How to find the percentage? Mass of sulfur divided by mass of organic compound into 100, right? So percentage of sulfur. So we are taking the mass of sulfur obtained divided by mass of the organic compound into 100. So this is a final equation. So you have to make a paper, chart paper like that. So take a piece of paper, full sheet, then write percentage of sulfur, what is the equation? Percentage of carbon, what is the equation? Percentage of hydrogen, what is the equation? Which method? What is the name of the method? Okay, we are studying about quantitative, how much amount is present. So that is about estimation of sulfur. So you can see some barium sulfate here. Okay, so estimation of sulfur, that is also done. Same method we are following. Based on the final product, we have to find the percentage. Then we have estimation of phosphorus. Okay, how can we find the amount, percentage of phosphorus present? Again, we have it to carriers too. We are calling it as carriers too. Okay, now we'll ask about that. Then again, organic compound is present. Of course, organic should be present there. Then we have to add something. Oh, fuming nitric acid, repeat, repeat, repeat. So same thing, we are repeating some difference in the reaction. So we have to check the reaction. Phosphorus, it exists in P4 state. Okay, phosphorus P4. Then we are adding HNO3. Then what is formed? H3PO4. So H3PO4 is formed here. Then after that, what I have to do? H3PO4, take it as. Then by adding ammonia and ammonium molybdate. So I'm getting ammonium phosphomolybdate. So this is a final product. So you have to remember the final product, ammonium phosphomolybdate. So here also 3, here also 3. Then 3, 4, 3 into 4, that is 12. So this is known as ammonium phosphomolybdate. This is the first method to estimate the percentage of phosphorus in an organic compound. So ammonium phosphomolybdate, that is formed. Okay, initially H3PO4, then we are adding ammonia and ammonium molybdate. So we got the final product. So keep it there. Okay, then one more. We can do one more reaction. So using the first one, you can find the percentage. If you want to find the percentage of phosphorus using the second method also, you can do. So this one, that is the first one. Then here, there's a second one. I have H3PO4. Can also be precipitated as magnesium ammonium phosphomolybdate. Okay. So first one, ammonium phosphomolybdate is formed. Here, by adding magnesium mixture, that is MgSO4 and the NH3. So you can form what? Mg2P2O7. So here Mg2P2O7, that is the final product. Okay. Magnesium pyrophosphate. You will study about magnesium pyrophosphate. Then what is the structure? So final product, first case, ammonium phosphomolybdate. Second case, Mg2P2O7. So using two different methods, we can find the percentage of phosphorus. Then we have to find the equation. So what is the equation to find the percentage of phosphorus? Okay, so what is the equation? So again, the same process. We have an organic compound. So what is the mass of organic compound? That is m gram. We are assuming it as m gram. The question paper, they will give the mass of organic compound. Then what about the mass of ammonium phosphomolybdate? So this is the first method. So final product is ammonium phosphomolybdate, right? So I'm taking it as m1 gram. So this is the formula for ammonium phosphomolybdate. Then we have to find the molar mass of ammonium phosphomolybdate. Okay, I'm giving you. Okay, otherwise it will take a lot of time to calculate. I'm giving the molar mass of ammonium phosphomolybdate, that is 1877 gram. Okay, in that there is one phosphorus. One phosphorus is present. Then we have to find percentage of phosphorus. So I will take it as 1877 gram of ammonium phosphomolybdate contain 31 gram. For phosphorus, it is 31, only one phosphorus. So 31 gram of phosphorus is present. Okay, so phosphorus that is present. What about the percentage or mass of phosphorus in 1 gram? How to find that? 31 divided by 1877 gram. Then we have M1 gram. In M1 gram, what is the amount of phosphorus present? 31 divided by 1877 into M1 gram. So we got the percentage. No, we got the mass of phosphorus. Mass of phosphorus divided by mass of organic compound into 100. Then we will get the percentage of phosphorus in the organic compound. So this is the final equation. Percentage of phosphorus 31 into M1. Then there is 100. We have converted into percentage divided by 1877. That is a molar mass of ammonium phosphomolybdate into M. That is a mass of organic compound. So this is the first method. What about the second one? If phosphorus is estimated as Mg2P2O7, so we need the mass, molar mass of Mg2P2O7. We can calculate. So for the time being, I'm giving the mass, molar mass. Mass is given as 222. Okay, 222. So that is a molar mass of our Mg2P2O7. So how many phosphorus present? There are two phosphorus. That is 2 into 31. So I will get 62. So in 222 gram of magnesium pyrophosphate, 62 gram of phosphorus is present. Then again, unitary method, in 1 gram, 62 divided by 222 gram is present. In M1 gram, okay, in M1 gram, so what is the amount of phosphorus? 62 divided by 222 into M1 gram of phosphorus. So that is a percentage. So how to find the percentage? 62 into M1 into 100 divided by 222 into M. Okay, here it is given 222. That is a molar mass of magnesium pyrophosphate. Then there are two phosphorus, so 62. So that is all about estimation, our estimation of a phosphorus. Then, so this is about estimation of phosphorus. So far, we have studied qualitative analysis and quantitative analysis. In the last class itself, we have studied, this is just to recall the things. We have studied majority of the things in the last class itself. Okay, so Tuesday, I think, Tuesday we have taken the last class. So you know how to find the percentage. So take a piece of paper or full sheet, then write all the equation. What is the name of the method? Dumas method, Geldas method, Lebig's method. Okay, so that is all about our organic chemistry, the basic things of organic chemistry. That is finished. Now we have to go to the advanced. What is this advanced? So we have so many reactions based on our general organic chemistry, our inductive effect, resonance effect, etc. We will predict the product of the organic reaction. So we will get a reactant. We will add some reagents. Then some product will be formed. In between, we have studied intermediate. So intermediate can be also formed. Then stability of intermediate, we have studied about that also. So we have to find in a chemical reaction, what is a product obtained or which are the intermediates present. Okay, in chemical reaction, it is not about directly reacting this converted to product. There are so many steps present. So we have to identify the procedure. So what are the steps going on? So we will study about the steps involved in a chemical reaction, organic reactions. Okay, so that is known as reaction mechanism. Then try to recollect all the points that we have studied from this chapter. So we are continuing our organic chemistry. So you should be an expert in organic chemistry after all these classes. So that is our aim. Okay, you are the center, you are the main thing. Then let us start. We have hydrocarbon. So in textbook, hydrocarbon is there. So name is same, hydrocarbon, very small name. So compared to our last chapter, it is a very small chapter compared to that one. Okay, but we will study about some reactions. Then what is the importance of this chapter? Next year also you will study about many organic reactions. This is a basic. Some reactions that we are going to study in this chapter will be repeated next year also. So if you study all those reactions now itself, it's pretty easy for you the next year. So that's the main thing. So let us start the chapter hydrocarbon. In hydrocarbon, we have already studied alkanes, alkenes, alkynes, then aromatic, right? Aromaticity, we have already finished that Huckel's rule, cyclic, conjugated. We will study about that. Then introduction, some introduction. What is alkenes? You already know what is alkenes. Then isomers and nomenclature. IUPAC nomenclature itself we have finished. Then is it needed to again study nomenclature? No, you are an expert now. Then preparation of alkenes. Preparation we have not studied. So that is a new thing for you. So introduction, I will give you some points that you have already studied. Nomenclature, I will just test that portion. Okay, so let us study about alkanes first. Then later alkenes and alkynes and aromatic hydrocarbons. So this is based on our IUPAC nomenclature. So write the structural formulas of the following compounds. How to write it? I will give you 30 seconds. You have to write the formula. No need to write CH2, CH3, CH2, double bond, single bond like that. You have to just draw the zigzag lines. We have studied that notation also. Okay, you can do it. You can do it. How to write? So name is given. From the name, we are going to draw the structure. So in IUPAC, in GOC chapter, we have studied this one. How to write this? This NEET exam. Your last NEET, 2021 NEET, they gave the name. You have to find the structure. Now need to draw that. You have to identify the correct structure. So how to write? So first you have to identify the word root. That is our heptane. Hep means there are 7 carbon atoms in the word root. So you have to draw it. So I am drawing 1, 2, 3, 4, 5, 6, 7. So next, what is the next procedure? You can start numbering from any side. So 1, 2, then I have 3, 4, 5, 6, 7. Okay, that is correct. In the word root, heptane, 7 carbon atom. Now, which are the branches or substituents present? In the third position, there is a 3, 4, 4, 5 tetramethyl. There are 4 methyl group. You know, third position, there is a methyl group. So this single line, that means methyl CH3 is present. What about fourth carbon? There is 2 methyl groups present. Then fifth carbon, there is 1 more methyl group present. So that is our answer. So no need to write CH3, CH2, CH2, etc. We can draw like this one. Then next one, we have 2,5-dimethylhexane. Dimethyl means there are 2 methyl groups present. Hexane. So first identify the word root. So in the parent chain, there are 6 carbon atoms. So we have to draw that. 1, 2, 3, 4, 5, 6. What is the next procedure? We have to start numbering 1, 2, 3, 4, 5, 6. So that is also done. Now substituent or branch. Second position, I can see a methyl group. So I'm drawing like this one. No need to write CH3 again. Then fifth position, fifth carbon, there is 1 methyl group. So fifth position, there is 1 more line I am drawing. So that is our methyl group. So this is the structure. So from name to structure, first identify the parent chain, then start numbering. Then there is no double bond, there is no multiple bond. Then go for the substituent or branches present. So that is a recall question for you. You might be saying, sir, this is very simple. We have done so many complex naming or structure to name to structure in IUPAC nomenclature. So it will be very simple. If you are studying high level questions, okay, if you are solving high level or high concept questions, these are very simple for you. But don't neglect this one. Simple questions are also asked in NEET, JEE, then KCET, then other entrance examinations, okay? So that is a recall. So let us start. What is the importance of hydrocarbon? Hydrocarbon means there is hydrogen, there is carbon also. In your biology, there is biomolecules, like carbohydrates. So here we are studying about hydrocarbons. If you are bio student, there is one more chapter there. Then there are also carbon and hydrogen are involved. What is the importance of this one? These hydrocarbons in daily life? Petrol or fuel, petrol, diesel, etc. Without fuel, we can't live. That is our modern world. If it is old days, bullock cart is there. Or you will walk to the school. Now it is not possible. We can't do that. Okay, it is possible, but we won't do that, right? So fuels, it is hydrocarbon, carbon, and hydrogen is present. Then your LPG cylinder, what is LPG? Liquefied petroleum gas. What is CNG? It is also used in new cars, CNG, compressed natural gas. So in all these carbon and hydrogen are present. Then polymers, you might have heard about PVC, polyvinyl chloride. So in polymers also carbon and hydrogen is present. Sir, we don't know about polymers. Don't worry. Next year there is a separate chapter for our polymers. Then some drugs. Okay, not that drugs. Medicines. So for making these medicines, we are using hydrocarbon as a starting material. Okay. Then there are so many examples. In all these things, hydrocarbons are present. So why we are studying this chapter? This chapter has good connection with our daily life. So suppose you are going to become a scientist. These things will be useful for you. We are scientists, make our life very easy. They are discovering new things, right? So these are the importance of hydrocarbons in our daily life. So let us start studying. Let us study about the reactions. Then only in the future you will be able to synthesize some new compounds, some new polymers, new drugs, etc. So this organic chemistry is very important. There are so many jobs related to organic chemistry, pharmaceutical industry. It is related to our organic chemistry. If your organic chemistry is good, then you can go there and you can do service to the humankind. Okay, so you can do other things also, no issues. That is also a service. So these are the different examples. First, we have studied this classification. Classification of hydrocarbon. I am classifying hydrocarbon based on the bond between carbon-carbon or bond between carbon-hydrogen. We have studied chemical bonding itself, right? So entire chapter for this bonding. So first we have saturated. Second, we have unsaturated. Saturated means carbon-carbon, only single bond. Carbon-hydrogen, that is always single bond, right? Then unsaturated, that it can be multiple bond, double bond or triple bond. Then last one, aromatic. Aromaticity, complete aromaticity we have studied. So we have studied the basics of organic chemistry. So this will be very easy for you, this chapter. So saturated, then alkenes. I'm classifying saturated hydrocarbons into two. First one, alkanes. Alkanes means open chain. C2H6, general formula, you know, CnH2n plus 2. That is a general formula of alkanes. Then we have cycloalkanes. Cyclo, that means rings are present. Closed chain. So first one open chain, second one that is closed chain. So what is the general formula? That is CnH2n. Then you will say, sir, this is for our alkenes. So let us find out for the alkenes. So here we have a cyclohexane. So this is our cyclohexane. So in my offline class, I asked the students, I drew the structure and I asked, they said, sir, it is benzene. I was shocked. This is not benzene. Okay, there is no bond. So by mistake, you will say it is benzene. But you have to see that properly. Okay, open the eyes and see that. So this is cyclohexane, not our benzene. There is no double bond present. Then unsaturated, that first alkenes are present. C double bond C. C2H, for example, you know CnH2n, CnH2n. Okay, then we have alkynes. There is triple bond between carbon and carbon. Any example? C2H2. So what is the general formula? CnH2n minus 2. Then aromatic. They are somewhat special type of cyclic compounds. We know benzene, that is aromatic. Then we have studied so many examples. We will study about that in the end of the chapter. Okay, so this is the classification of hydrocarbon: saturated, unsaturated, aromatic, saturated alkanes and cycloalkanes, unsaturated alkenes and alkynes. Then our aromatic, right? So IUPAC nomenclature, okay. Then this one, okay. Then preparation of alkanes. We have to study about the preparation or methods of preparation of alkanes. How can we prepare alkanes? Alkanes means carbon-carbon, single bond. Then carbon-hydrogen, there is a single bond, right? So there are different reactions for the preparation of alkanes. So let us find it out. First one, from unsaturated hydrocarbon. So what is this unsaturated hydrocarbon? That is, it can be double bond or triple bond. Double bond means alkenes. Triple bond means alkynes. So this is also known as hydrogenation. Hydrogenation means we are adding hydrogen. Okay. So what is happening here? Reduction. Addition of hydrogen, that is known as reduction. So catalytic reduction means some catalyst is present. So what is the role of catalyst? Okay. So first I'm taking an alkene. What is the general formula? CnH2n. I'm adding hydrogen, so I can call it as hydrogenation. Addition of hydrogen, reduction. Then catalyst, platinum. Pt means platinum. Pd means palladium. Ni means nickel. So these are the different catalysts. Or you can use different catalysts are present. PTO2. PTO2, platinum. Okay. PTO2 you can use. Or you can use Rani nickel. You can use Rani nickel. So what is this Rani? It's not Rani, okay. It's not a girl. So what is this? So nickel aluminium alloy. Alloy digested in aqueous NaOH. Aqueous NaOH. So that is our Rani nickel. So these are the different catalysts. In the presence of catalyst, we are adding hydrogen. So we can call it as catalytic reduction. So what is happening here? Unsaturated to saturated. Alkene to alkene. For that we need one H2. Then what about alkyne? Alkyne CnH2n minus 2 plus we need 2H2. What is formed? Again alkane. So saturated compound is formed from unsaturated to saturated by the addition of hydrogen in the presence of catalyst, that is known as catalytic reduction or hydrogenation. Okay, alkene to alkane, one hydrogen, one H2. Alkane to alkane, that is there are two H2 present. So what is happening? Or I will tell you one more term. So what is that? So I can call it as degree of unsaturation. Degree of unsaturation. So what is this degree of unsaturation? DU. So DU, that is Delhi University, right? So degree of unsaturation, what is that? That means we have an unsaturated compound. We want to make it to saturated. For that, how many H2? How many H2 is needed? So that is known as degree of unsaturation. Some clarity is missing, right? So let us take the example. Suppose I have C2H4, right? That is alkene, unsaturated. I want to convert it into C2, alkane, ethane. So what is the formula? CnH2n plus 2. That is C2H6. For this conversion, how many H2 I have to add? So I have to add one H2. So in the case of this alkene, Du, that is 1. Suppose I'm taking a C2H2. I want to convert it into saturated, that is C2H6. So how many H2 is needed? So look at here, H2. Here it is H6, 4. 4 means I have to add 2H2. So what is the degree of unsaturation here? That is 2. Okay, there are some other names for degree of unsaturation. That is known as DBE. What is DBE? That is double bond equivalent. That is our DBE. Or there are some more names. That is index of hydrogen deficiency. Index of hydrogen deficiency. All of these terms, that is same. So I can write it as IHD. So degree of unsaturation, double bond equivalent, or index of hydrogen deficiency. That means how many H2 is needed to convert an unsaturated compound to a saturated. So that is it. So in the case of one more example for you. Here we have a cyclopropane. So this is our cyclopropane. So I want to convert that. So this is C3H6. I want to convert it into saturated. So saturated, or here ring is present. I want to remove the ring. So if I remove that, I will get C3H8 propane. How many H2 is needed? I need one H2. So one H2. So what is the point? If double bond is present, Du is 1. If triple bond is present, Du is 2. If one ring is present, for one ring, Du is a 1. Okay, so that is degree of unsaturation or double bond equivalent or index of hydrogen deficiency. How many H2 is needed to convert a unsaturated compound to saturated? I hope this is clear to you. This one, very simple one, right? So that is our first reaction, hydrogenation. So let us take some example. You have to practice. So you have to practice more number of questions. So we have a alkene here. So how to convert it into saturated by the addition of hydrogen in the presence of catalysts like platinum, palladium, nickel, etc. How to do that? So just break this double bond, right? Then add one hydrogen this side, add one hydrogen this side. Then what is formed here? So we have CH3, a single bond, CH3. One more thing to remember, both this hydrogen, they're added to the same side. Suppose they are coming from below. So both of them are coming from below position. Suppose if one hydrogen is coming from above, okay, other will also come from above position. So they are coming from the, both groups are coming from the same side or attacking on the same side. So that type of addition is known as syn addition. Syn addition. They are added to the same side. Syn addition. Okay. So important hydrogenation, it is syn addition, right? So ethene to our ethane is formed. So here we have propane, then hydrogenation. So what to do here? Break the bond, hydrogen, hydrogen from the same side. So I will get an alkane, CH3, add one hydrogen, CH2, then one more, that is CH3. So propene to propane is formed. Here what is formed? Ethane is formed here. Then third one, I have a triple bond present here. Alkane is present, right? Then here what is degree of unsaturation? Du, that is equal to 1. I need only one H2. So what is the du here? Du is equal to 1. So what about here? Du is equal to 2. Degree of unsaturation or index of hydrogen deficiency. So how to do this? How to do this? I had to break this double bond also. So hydrogen, hydrogen. So one more hydrogen, one more hydrogen. So what is formed here? What is formed here? So I had to write CH3, then a CH2, then a CH3. So again, I'm getting propane. So very simple reaction, hydrogenation reaction. So you have to remember, syn addition is happening. Both hydrogen coming from the same side. Okay, so that is about hydrogenation. This is the first method of preparation of what? Alkanes, not alkenes, not alkynes. I hope this is pretty clear to you. Very simple reaction. So with this, we have studied degree of unsaturation also, right? So next one, from alkyl halides. So what is alkyl halide? Halogen we know, that is X. Alkyl group that we know R. So I can represent it as RX, RX, that is alkyl halides. There is a separate chapter for alkyl halides, haloalkanes and haloarides next year. Okay, so you will study about that. So alkyl halides, so fluorides, we are not taking fluorides. Okay, this R and fluorine. So bond is very strong. It is very difficult to break that bond. You will study about that. Then RCl, RBr, Ri. We will study the reaction of these alkyl halides. So what is the reaction happening? Again, reduction is happening. Last case, catalytic reduction, hydrogenation. Here also reduction. In the presence of what? We have Seden and dilute HCl. So what is a product form? Alkanes. So what is a reactant? Alkyl halides. In the presence of Seden plus dilute HCl, reaction takes place and we are getting alkenes. We should get alkenes, right? So we are studying about methods of preparation of alkenes. So let's take an example. So we have chloromethane, IUPAC nomenclature we have studied. So that is haloalkane, haloalkane. That is the name, haloalkane. Here chlorine is a halogen. So we will call chloro. Then what is alkyl group? Methyl is alkyl group. So methane, chloromethane. In the presence of Seden, H plus. What is H plus? That means acid, can be HCl. Okay. So what is happening? We have CH3. How to remember this one? CH3, there is Cl. Remove that Cl, add one hydrogen. So I will get CH4. That is our methane. Then hydrogen, one hydrogen is remaining here, right? So one hydrogen is remaining here. So HCl is formed. Hydrogen and ClH plus and Cl minus, we will get HCl. So chloromethane to methane. That is a one reaction of alkyl halide, right? Example for you, one more, chloroethane. What is halogen? that is chlorine. So chloroethane plus H2 in the presence of Z and H plus. I'm getting ethane. So what to do here? C2H5. Instead of this one, add a hydrogen. So I will get C2H6. That is ethane. That is the simplest way to remember this reaction, right? This reaction is not that much importance for us now. Okay. Then what is important, sir? Important is Wood's reaction, name reaction, right? Wood's name reaction. That's a name reaction. Wood's reaction. In the Wood's reaction, we are taking alkyl halide. What is alkyl halide? That is Rx. How many alkyl halides? We are taking 2 Rx. So here you can see 1 Rx. Here you can see XR. What is XR? That is Rx itself, right? Then sodium metal we are taking. That is 2Na. 2Na, that is our sodium metal. Sodium metal, it is highly reactive. So to control that, we are taking dry ether. So dry ether, it can be this one, C2H5. Oh, C2H5. We have studied this ethoxy ether. Okay, in IUPAC nomenclature, we have studied about ethers. So to control that, we are taking dry ether. What is happening? So here, this is one family. So this is like a Bollywood movie. So here we have one brother. Then another brother is present here. They're isolated, completely isolated. After so many years, they are meeting. Okay. Then they are coming together. R and R, not triple R. So last year, our triple R, it has won some awards, right? R and R. Then what is remaining? We have Na, we have X. So NaX is formed. So here 2 Na, 1 X from here, 1 X from here. So NaX, NaX. So I can say 2 NaX is formed. So what you have to do? Rx, separate halogen. Take the R, first brother. Then second alkyl halide, separate halogen. We have R group. Then join them. R and R, that is our alkane is formed, right? Suppose we have 2 CH3X, 2 Na in the presence of dry ether. So what is formed? So take the first brother, that is CH3. Then second brother, that is CH3. So I will get ethane. You have to just join that. So that is a reaction. What is the name of this reaction? Wood's reaction. This Wood's reaction is very important. Next year also you will study about Wood's reaction. So it is better to study about Wood's reaction now itself. Then your thought will be very easy, right? So that is about our Wood's reaction. So we have to find the mechanism. So what do you mean by this mechanism? Mechanism means what are the steps involved in the reaction. So let us check the steps. So remember, we are taking sodium in dry ether, right? So some examples, no examples for you. Let us study the reaction. So what is the mechanism? Which are the steps involved? So first I am taking a sodium. I have sodium. What about sodium? It is a metal. Metals are generally electropositive in nature. So sodium, it is giving 1 electron. So Na plus 1 electron. They are electropositive. They are electropositive in nature. They are electropositive in nature. So they are ready to give electron to other species. Okay. Then second step, in the second step, we have Rx. What is Rx? Our alkyl halide. So our alkyl halide is present. Then what is happening? What is happening here? This halogen, it is highly electronegative. Okay. So it is taking the electron from this bond. So this will take the electron and go far away from our alkyl group. So it is taking electron. It is highly negative, very bad guy. So X minus is formed. If it is taking, then R plus should be formed. But R plus is not formed. So what is happening here? Alkyl group, carbon is present. It is taking 1 electron. From where it got 1 electron? That is sodium is releasing 1 electron. So R plus 1 electron. Then what is formed here? R and this 1 electron. That is free radical. So this is known as free radical. We have studied about free radical work in reaction intermediates. So in this reaction, what is a reaction intermediate? That is free radical. So our alkyl group is taking 1 electron. So R plus is not formed, free radical is formed. Suppose one free radical is formed. Then after some time, another free radical is formed. They will say, okay, my brother, come. So R free radical and R free radical, they will combine together. So I can call it as dimerization. So third step, what is happening here? Third step, R free radical with another R free radical, they combine together to form RR. What is RR? That is single bond is formed. So this is our alkane. So alkane is formed in this reaction. The second step, that is a slow step. Okay, that is a slower step. There are three steps. Second is a slower step. That is a rate determining step. Why slower step? Suppose I'm participating in a running competition. I'm not an athlete. Okay, then all three runners are very fast. I am the slowest one. Then what about the total time required to complete 1,600 meter or 1,000 meter? So it is decided by the slowest runner, that is me. Similarly, in the reaction rate, we have to find the time taken for the reaction to be completed. So the slowest step will determine that. So slowest step is known as rate determining step. Rate determining step. You will study about rate determining step. Next year, there is a complete chapter known as chemical kinetics. So slowest step is known as rate determining step. So this is a mechanism of our Woods reaction. Okay, examples C2H5 Br, 2Na, Br, C2H5. I'm taking 2 C2H5 Br. What you have to do? Take the first brother, take the second brother, join them, right? So what is the product obtained here? Butane, C2H5, C2H5 plus 2NaBr, that is also formed. So that is the first example. What about the second one? Here we have CH3, bromomethane. Here also bromomethane. Take the CH3 from here, CH3 from here. Then join them together. Then what is formed? I will get ethane plus 2NaBr. So look at here. I'm getting butane. I'm getting ethane. So they contain even number of carbon atoms. So what about odd number of carbon atom? It is very difficult to form this compound, organic compound with a odd number of carbon atom using Woods reaction. That is a limitation of Woods reaction. So generally, Woods reaction will give organic compound with even number of carbon atom. So you have to remember the limitation. Based on this, there is a previous year question. So what about odd number of carbon atom? Yeah, it can be formed. But in that case, mixture of products will be formed. There will be a compound with odd number, one with even number, etc., etc. Then it will be very difficult to separate these out. So that is why we are not using Woods reaction to prepare organic compound or hydrocarbon with odd number. Okay, we usually form even number of carbon atoms in the Woods reaction. So that is about our Woods reaction. So this is a final question for you. So question, you can answer this question. Which of the following alkane cannot be made in good yield by Woods reaction? Woods reaction, that means even number of alkanes. What about odd number? No, no, no. So check the hydrocarbon with odd number of carbon atom. Hexane. Hexane means 6. So it is even number. So we can form hexane using Woods reaction. Butane, 4 carbon. Yeah, that is correct. Dimethyl butane, that is also even number of carbon atom. 7 carbon atoms are present in heptane. So we cannot prepare heptane in good yield using Woods reaction. So there are some other methods for the preparation of heptane, that is odd number of carbon atom, not Woods reaction. So Woods reaction, we can use it for even number of carbon atom. So this is from NEET 2020. Very simple question, but you have to do that. So one homework question for you. Homework question for you. So this is our alkyl halide. So this is our alkyl halide. Then there are two, here also 2Na in the presence of dry ether. In the presence of dry ether. So what is the product obtained? So what is a product obtained? One is NaCl, 2NaCl, or what is a major product? So that is a homework question for you. Okay. So homework question and last concept question from NEET 2020 we have done. So that's all for the day. So we will meet you in the next class. So happy Pongal, happy Sankranti. Then bye-bye students. I'm ending the meeting. I'm ending the meeting here. Okay, JNV Mahi students, we will meet in the next class. Okay then, bye students. Enjoy your day. I'm stopping it here.